Hello and welcome to C++ Weekly. I'm your host, Jason Turner. In this episode, I want to call your attention to using C library functions from C++. The first thing that I want to point out is that almost all of the examples are broken that you'll find. And the second thing that I want to tell you is that it's possible to do better with some very simple wrapping. Well, I guess the example that I ended up with is more complicated than I intended, but you'll see what you think in a moment here. Yes, my name is Jason Turner. I am available for code reviews, on-site training, that kind of thing, contracting. Go ahead and send me a note if you have any interest in my services. This episode is sponsored by JetBrains, and I wanted to let you know that I do personally use CLion in my work. I find the refactoring tools to be particularly valuable. The safe delete feature has saved me a ton of time when I've been doing refactoring on large projects. And great news, everyone! As of May 7th of this year, JetBrains has decided to make CLion free for non-commercial use. Be sure to check out the video description for more details on that. So let's go ahead and look at the man page for fread here. This is pretty typical. Well, this one's slightly better than average, but it's still pretty typical. First of all, the example has a fixed size buffer, and that's probably okay, but you have to be careful to make sure you get that fixed size buffer the right size for the fread function or whatever other function you're using. The next thing is this does an fread here on the file open, and if there's an error, then it immediately does an exit failure. Well, it's true that if you exit from a program with a file handle open, that the runtime is going to automatically shut that for you. It's going to call close on it as it's cleaning up your process. But if you're copying and pasting this code, you're probably just leaked a file handle here. And same thing for down here. You've probably just leaked a file handle if this didn't do exactly what you expected it to do. Basically, 100% of the POSIX man pages are like this. If you blindly copy this code, you're going to end up with something that leaks resources and does not have complete error handling. I went down the road of trying to make a relatively simple episode of just how to use fread safely. That was the original title of this episode, was Using fread Safely. And I ended up with a wrapping C functions kind of episode instead. So instead of typing this out as I normally would, I'm going to show you what I ended up with. This is not meant to be a canonical example. This is not meant to be something that you would 100% replicate, but perhaps something that inspires you to think at a higher level and make your own code easier and safer to use. We're going to start at the bottom and work our way up. This is executing on Compiler Explorer, just for the record, and I am in fact opening dev random on Compiler Explorer, and I believe this is intentionally allowed, and it is at least moderately safe. I am calling my FOPEN here. So this is a wrapper around FOPEN that I have written. I was not terribly creative with the function name. This takes a file system path object and a ModeString. This is similar to FOPEN, which requires a path and a string. Now, note I have made my wrappers strongly typed here. If I try to call this with just a string, I'm going to get a compile time error. So you do have to actually pass a file system path and a mode string in that order. Now I'm going to say I want to read some of my data objects. I want to read 10 of them, and I want to read them from this file handle f. Now I want to just do some debugging. So the actual use of FOPEN and fread is literally just these two lines of code, 100 and 104, and everything is safe after that. Code written to make sure that file handles clean themselves up and errors are properly handled. So in here I have this thing that prints out whether or not there were any errors, and then it prints the resulting elements that happened to be loaded from this thing. So I'm just going to go ahead and I'm going to revert this back to just a slash here. I'm going to say that I want to open the root directory. You will observe in my program output over here on the bottom right, when this is done executing, that I get there's an error that occurred, and the error was that I tried to open a directory that I treated as a file. Well, thank you very much for doing that correctly for me. Okay, now let's scroll up and we're going to look at my FOPEN first. This thing takes a file system path, and if you've watched my conference talks and such, you know that I am rather annoyed at all of the implicit conversions that exist in the standard library. So file system path is in fact implicitly convertible from a number of things, but I disable that 2 lines down from here. And I take a ModeString. This ModeString is my own type that I have declared above this that is not implicitly convertible from anything. I return a file handle, which is the result of calling FOPEN, and I'm passing this thing a function pointer to fclose. So my file handle is actually just a type def for a unique pointer that has fclose as its custom deleter, so whenever the unique pointer to file pointer goes out of scope, it knows to close the file pointer. Now, I did this, which is a little heavy-handed. I said delete all possible overloads to my FOPEN. And if I try to call this thing with anything other than a file system path or a ModeString, I'm going to get a compile time error. Continuing up, we will see my ModeString type. This is an explicit constructor that takes a const character pointer, and I have made this const eval. So this must take a compile time determined ModeString. You can argue about whether or not that makes sense, but for the sake of this example, this makes this thing perfectly safe. I know that at compile time, I'm choosing what type of ModeString I want to use to open this thing, and I know that this string must be valid for the lifetime of the program, otherwise the const eval code wouldn't compile, so this has got an extra layer of safety. My actual read function is relying on documentation that I got from CVP reference, so it's possible that my call to fread is not 100% correct, but that is fixable with using bitcast. I am in here first checking to make sure that the file handle that I got was not null pointer. If it is null pointer, then I am returning a result object that says I received an invalid file pointer. Then I am constructing the exact type that I want to return, and I'm doing that to make sure I get named return value optimization and there's no chance of a copy or even a move of the elements that have been read. I am going to use the designated initializers from C++20 that allows me to initialize each of these elements. So I'm initializing the actual vector of elements that are going to be returned here with count. So it is going to default initialize all of those elements. You could argue that there's an extra cost there, but these things must all be trivially copyable. So it's going to just be a memset of zeros. Not too concerned about that. And I'm defaulting the result to say that yes, a full read did occur and there was no error string. Now I'm doing an fread into the elements of the data here. Now, CVP reference says that this is valid if the thing is trivially copyable. But I couldn't find any wording specifically in the standard that allows this. As far as I know, fread is not a magic function like memcopy. But like I said, this is fixable with bitcast if there's a miscommunication into whether or not this is valid. And I'm telling it that I want to read size of type elements, count of elements. This is the count that was passed in to the function call here. And then I resize the read elements to the number of elements that were actually read. If the number of elements read did not match the requested count, then I figure out why. Was there an error or was it an end of file? If it was an error, then I properly get the error string. If it was not, then I set the end of file marker, and then I return the results from this thing. So that's going to be well performing and safe. It's impossible for me to leak any memory, file handles, or anything here. And then I have a concept, this is trivially copyable, that makes sure that the only types of things that I try to read are trivially copyable, and that's going to be required for both my understanding of fread or if we needed to rewrite this to use bitcast. And you can see my file handle here, which is an alias, just a using declaration for a unique pointer to a file, and this decal type of the function pointer of fclose so that it knows how to automatically destroy the file pointer when the unique pointer wrapper goes out of scope. The final thing here that is of interest is my read result struct, which I have made the struct itself no discard. So now it becomes a warning if I ever ignore an object of type read result. I don't have to now decorate my function to say that no discard here. I can just put it on the struct. And as I said, it's just a vector of the elements read, a result, which is the enum struct here to let us know if it was a full read, a partial read, and why it was a partial read, or whether or not I received an invalid file pointer, and a string representing the error string if one occurred. This thing is not going to allocate unless it needs to, and it should be pretty efficient to move or copy, but we're going to get named return value optimization anyhow, so that becomes irrelevant. That is a walkthrough of my type safe wrapper. I spent maybe an hour working on this, and it is, 92 lines of code, including comments. Now this thing is infinitely reusable in the rest of my code, and I never have to think again when using FOPEN about the error handling or the lifetime of the objects or the lifetime of the file pointer or the resources that are being used, because I know RAII, constructors and destructor pairs, are going to take care of all that for me. And I also know that I can't accidentally swap the parameters to this thing because they're strongly typed now. So hopefully this episode just gave you something to think about and how you might spend a little bit of time wrapping your otherwise not type safe or memory safe or resource safe functions with ones that are, that can be called nice and cleanly and easily from your C++ code. Thank you for watching this episode of C++ Weekly. Be sure to subscribe. I'll catch you later.